today what we are going to be doing is we're going to be learning how to write names for ionic compounds. And it's a fairly simple process. There's just a couple different rules that we need to follow. So let's take a look at a couple of them. Now for doing this, you are going to have your ion sheet handy. And your ion sheet will look like this. And it's in your handbook Mr. Kleinschmidt and I gave you. So if you don't have this, make sure you get a copy of this. And it has the positive ions or the cations you need and all of the anions you will need as well. So make sure you have this handy, and if not, please see us right away to get one. Alright, so let's take a look at a couple of the rules. Alright, the first thing you're going to do is name the metal ion or the cation. That's the positively charged one. And then you're going to name the anion. The anions always end in "ide," "ite," or "ate," one of those three endings. Okay, so let's go ahead and get into some simple rules. So if you have to hit pause and write the rules down, go ahead. Or if you are using QuickTime, just go ahead and hit pause and you can file and print this. Alright, so let's take a look at some examples. Alright, so what we want to do here is we want to write the formula, and let's name the formula. So if we have these two ions, you have this ion right here and you have this ion right here. Well, one way to do this is just look at your ion sheet and say, well, what ion is this? This is the lithium ion. Look at your ion sheet and say, well, what ion is this? That is going to be the sulfide ion. So to name it, it's fairly simple. You say, okay, that's lithium. Okay, and then sulfide. Okay, so we're kind of doing this a little bit backwards because it's easy doing this way. Just look at the ions and name the ions. But let's say if we wanted to put the formulas together, well, what is lithium sulfide? So you cross your charges. The 1 will come here. The 2 will go right there, and you say lithium will have a 2 subscript at the bottom, and sulfide will have a 1. So that is my formula, Li2S, and that is the formula for lithium sulfide. Let's take a look at another example. So let's go ahead and let's do the formula first. Remember, the 1 will come right here, but remember, in chemistry, we don't do anything with 1. So if you have a 1, it's implied by just having one symbol. Okay, so we say the sodium, which is Na, it's going to have a little 3 right here. The N will have a 1, but you don't have to put the 1 there. And you say, well, what is this thing? So what is this ion right here? That is the sodium ion. Okay, and this right here, this N, is nitride. So sodium nitride. Okay, and its formula is Na3N. Let's take a look at this one. Now, what we're going to start getting into is looking at the transition metals, and sometimes transition metals can have more than one charge. They can have up to 3 or even 4 charges, but we're going to look at just the basic ones today. We're going to take a look at, this is copper. Copper can have a +1 charge, or copper can have a +2 charge. So what we want to do is we want to name it and write the formula. So let's go ahead and let's do this. So if we take a look at this one, remember, the 1 right here will come right on the outside right here, and the 2 will come right over here. So for my formula for this first one, you have Cu2SO4. Now I'm not going to put the 1 here. Remember, the 1s aren't implied. So since this is copper with a +1 charge, to write its name, all right, you write copper, and since it does have could have more than one charge, you have to put what charge it is in Roman numerals. So we're going to put a Roman numeral 1. And then SO4, that is going to be sulfate. Okay, over here we do the same thing, but take a look. This is a +2, that is a -2. Those charges just simply cancel out because you only need one of these for every one of these to make it a neutral compound. So you can write CuSO4. Okay, and to write the name for this one, you say, well, this is also copper, but this is copper with a +2 charge, so we have to put the 2 in Roman numerals. So this is going to be copper 2 sulfate. Now let's just real quick write down the Roman numerals in case you forgot them. Alright, so 1 is going to equal an I, 2 is going to equal an II, 3 is going to be 3 I's, 4 is going to equal an I and a V, and 5 is going to equal just a V. We're not going to get anything into anything higher than a 5 really in here. Okay, so we're just looking at 1, 2, 3, and 4 basically. Alright, so these are the Roman numerals. In case you forgot, just go ahead and just jot them to the side of your note guide. Alright, let's take a look at a couple more examples. Okay, for here, what we want to do is, if you're given the formula, name it. Alright, so this is not that hard to do, but one way you can do it is just by identifying and say, okay, what is this K thing? What is this K? And what is this thing right here? Alright, if you want to do this, this is what I kind of recommend. Just undo the charges or undo the crossing. So we know that K is going to have a +1 charge, and the 1 was kind of right here, and you just undo it basically. And this 3 is going to come right back up here. So phosphate has a -3 charge. Now you just identify and say, okay, what is K +1? That is going to be potassium. And what is this PO4 with a -3 charge? That is going to be phosphate. Okay, and that's what potassium phosphate is, K3PO4. Another way to do it, just by look at the K, look at the PO4. Once you start getting comfortable with this, it'll be like second nature to you. You'll be able to do this very, very easily. Let's take a look at this one. Oh, we got some, let's see, you got some CN and some FE. Now there's 2 of them, so that must mean that this element right here, or this ion, must have more than 1 charge. Okay, and in actuality this does. So we take a look at this right here, and you say, well, what is this thing? So CN, my trick is, here's what I would like for you to do. Okay, look at the anion first. Okay, because the anion will give it away what charges. So look for CN. CN is going to be a -1 charge. So that means that this 2 came from this Fe. That means they have to have a +2 charge. So we're looking at Fe with a +2 charge and CN with a -1 charge. This is going to be iron. Fe is iron. And since it is a +2 charge, and it can have a +2 or 3, we're going to put that 2 in Roman numerals, and CN with a -1 is cyanide. Okay, so we say this is going to be iron 2 cyanide. Do the same thing over here. We know that the 3 has to be over here. It came from the iron. And there was a kind of a little 1 here, but remember, we don't put the 1s, and that goes back up there, so -1. So we say iron with a +3 charge, cyanide with a -1 charge, and this is going to be iron 3 cyanide. Okay. Let's take a look at a couple more examples, because I feel like the more examples you get and the more examples we do together, the easier this will be. Alright, let's take a look at this one. It says, write the formula for the given ionic compound name. This is also somewhat simple to do once you see a couple of examples. So let's take a look at this. Alright, so if you're given the name and you have to write the formula, the simple thing is just say, well, write down its ion. So you say, what is the sodium ion? You look on your ion sheet and you say, okay, sodium has a +1 charge. What is the peroxide ion? It is O2. I almost have a dead spot on here. O2 with a -2 charge. You simply cross your charges, so the 1 will come down here, the 2 will come down here, just like what we've been doing, and you say, okay, this is Na2O2. Now, the one thing people will ask is, do I have to reduce this? And the answer is no, because if you get rid of this 2 on this peroxide ion, that's no longer peroxide. Okay? So you have to think, well, does this change the ion what it is? That little 2, remember, has to stay with that oxygen right there. So you cannot reduce this. So this is what the answer is. Sodium peroxide is Na2O2. Okay? Let's take a look at a couple more examples here. Oh, more peroxide. We know what peroxide is. We just did that one, so let's go ahead and write that down. So that's O2 with a -2 charge. Now we got tin, and remember what Roman numeral IV is. That's 4. So this, we look in our ion sheet and say, okay, where is tin? Tin is SN, and IV, that means Roman numeral 4. So it's going to be tin with a +4 charge. Now, one way to remember the formula for tin is, a lot of people are like, well, I don't remember because there's no S in tin. This sounds kind of corny, but just remember, tin is a sin, and you're like, oh yeah, look at that. Yeah, now I see. Okay, that's just one way that you can kind of remember that tin's formula is going to be SN. All right, we do the same thing. Oh my God, I wrote them really far apart today. So the 4 will go right there. My 2 will come down right there. And we say SN2O2. Remember that 2 has to be with that ion, or with the O. And then we have a 4 on the outside. Now, we have to include this in parentheses for clarity to indicate that we want 4 of these things. But now remember, with ionic compounds, you want the simplest ratio. So we want to know for every how many of these do we need one of these. If you think about this, like what Mr. Kleinschmidt already said, let me go ahead and change the color just for a second. You say, okay, for every 10 plus 4, how many peroxides do we need for this to be a neutral compound? So you have an O2 with a -2 charge. So when we add these up, that is plus 4 minus 2. All right, that's still a positive 2 charge. So we just add one more. And notice right here, that's -4 plus 4. So we need one of these and only 2 of these. But when you look at the ratio of the atoms here, the ions, you have 2 of these and 4 of these. And notice that this can be reduced right there. All right, so we're going to divide both of these by 2. And this is going to become SN. And then in parentheses, O2 and 2. Kind of what we did right here already. Okay? So this is going to be my formula for SnO2 with another 2 right here. So this is tin for peroxide. Okay? Just make sure you be careful with reducing. If you need help, just ask. Just remember that, but that 2 has to be with that oxygen right there. Alright, let's take a look at another one. Zinc hydroxide. And you say, okay, zinc, you have a +2 charge. Hydroxide, I got you. -1 charge. Okay? And I found both of those from my ion sheet. You cross your charges, the 2 will come down here. The 1 will come down here. And you say, oh, I got this. ZnOH2. If you leave it like that, that is not correct. Alright, but remember, this is a polyatomic ion. If you have a polyatomic ion, remember poly means many, atomos means atom, so many atoms in an ion, you need to, if it's anything other than a 1, like 2, 3, or 4, coming down over here, you have to include it in parentheses. So the answer is really Zn in parentheses OH2. Alright, pay special attention to poor hydroxide. He's just kind of misunderstood. He always gets left out. He's never in the parentheses. A lot of people always forget about him. Don't forget about the hydroxide. Okay, make sure your formula is this for zinc hydroxide. Okay, just don't forget about parentheses. That's the only thing that people really miss on hydroxide. Just making sure it's in parentheses. Okay, here we got mercury 1. We know mercury is kind of goofy, so let's take a look at mercury 1. That's Hg2 with a +2 charge. Now remember, that 2 has to be with the Hg. Nitride is N with a -3 charge. Where do you get those from? Ion sheet. Cross charges. 2 will come down here. The 3 will go over there. So we have Hg2. Now I have to put in parentheses for clarity, so I know that I want 3 of those. And we have an N2. Okay? That's mercury 1 nitride. Alright, here we go. Mercury 2 nitride. So it's basically similar. Let's take a look at this. So we have mercury 2 is Hg with a +2 charge. Nitride is N with a -3 charge. This one's simple. 3 comes here. 2 goes there. Hg3, N2. Alright, take a look just the difference between mercury 2 nitride and mercury 1 nitride. With mercury 1, you just have this little 2 right here, and we need 3 of those. So you're just going to enclose this in parentheses so it doesn't look like we need 23 of those. Alright, that's why the parentheses help clarify things, just so we know we don't need 23 of those, and we just need 3 mercury 1s. And there's mercury 2. Alright, let's take a look at mercury 1 sulfide. So we have Hg2 with a +2 charge. Sulfide, you are an S with a -2 charge. Hey, look. Equal but opposite charges. They cancel out and just write the symbols together. Just kind of squish them together. Hg2, S. And I'm done. Okay, for a lot of these, you're going to start seeing some simple tricks on your own, and that's awesome. If you could identify these tricks on your own, you're going to do a very good job at doing this. So make sure you're just paying attention, writing the notes down, writing the examples down. Remember, if you need help, please clarify, okay, or ask questions as I'm coming around helping you. All right, last example for the day. Let's see, it says, write the name of the following ionic compound. Remember, here is my trick for this. This might seem pretty simple, but it's not as simple as it looks. This is what not to do. All right, people are going to say, oh, okay, I uncross the charges, so that's going to be, lead 2, and, there's a 1 here. Yeah, okay. So people are going to say that's going to be, oh, I already messed that part up. Let's go ahead and undo. People are going to say that this is going to be lead 2 carbonate. No. That is not correct. Don't assume things right at the beginning. Remember, if you are unsure about something or something might look a little goofy, remember, look at the anion first. Okay, that is going to be the biggest thing to do. Look at the anion. Remember, when you uncross the charges, you say carbonate. I thought you have a -2 charge. Well, carbonate does have a -2 charge, but look right here. It's not here. Where is that 2? 2's not there. But look right here. There is a 2 here. All right, so we know that 2 or something came from up here. All right, and this 2 has to be right here. So it's supposed to be a -2 up here, and it looks like a +2 right here. If this is the case where if it's divided by 2, chances are this has just been reduced. So that means, okay, that this is going to be something that was simplified. So you just got to identify and say, well, all right, what was it simplified from? So you say, okay, I know that you are supposed to be a -2 carbonate because that's what the anion is for the carbonate. And you say, well, if that was, if this is kind of like a 1 down here, and when I bring it up here and I multiply it by 2, that means I take this, bring it up here, and I have to multiply it 2. So that means that's a +4. All right, so this is actually lead 4 carbonate. Okay, not lead 2 carbonate. Make sure you pay attention to that, because if you have to multiply by 2, all right, that means you have to multiply that by 2 to get your anion. Just be careful with those. Just remember, there's a couple of them with polyatomic ion, or I'm sorry, not polyatomic. There's many of them with multiple charges. Remember, be careful with lead, tin, copper, or copper. I just like to make fun of Boston people. Iron, antimony, and mercury. I believe those are only the ones that we are going to... Mercury. I spelled it right. I was like, what? Doesn't look right. Okay, just be careful with these down here. These are the ones that you will definitely need to pay attention to. Just kind of keep in mind when you're doing this if they're going to be simplified or not. Okay, so this should be lead 4 carbonate. All right, what I want you to do is try these on your own. Bring these back tomorrow on your note guide. It's in your textbook, page 273, problem 10, A through D. All right, it's not very intensive. It'll take you about maybe a minute or 2 minutes to do. If you have any questions, please make sure you bring your questions to me or Mr. Kleinschmidt during class, and we'll be more than happy to get these solved for you. All right, thank you for watching.